All right, we are on to our next installment here in our series, and what we're going to talk about today is polyatomic naming. Polyatomic naming it's simple to identify, more than two atoms. So anytime we're looking at three or more different types of atoms, we follow over here to the right-hand side of the polyatomic. Now, it is split into three groups: molecular, ionic, and specials. We're going to focus on the main group of these, and the main group of these is the ionic down the middle. Okay? And so what we want to look at here is we want to look at how do we determine it's ionic. Well, first of all, we're looking to look at how many types of atoms in a compound. Right here, if I look, I've got 1, 2, 3, 4 different types of atoms. That automatically qualifies it as polyatomic. Okay? Then, as before, we're looking to see, is it got metals or nonmetals? And in this case, we have a metal and a large group of nonmetals. Okay? But anytime there's a metal, we automatically assume that the metal is going to place it then in the ionic grouping. Really, folks, at the heart of it, that's what we're looking for. How many kinds of atoms, and are there metals or nonmetals? After you get that, everything's into their separate groups. You get to use your naming rules. So right now we're looking for metal and ionic. Okay, so this compound has a metal, and it's got HCO3. Well, we're going to come across lots of different kinds of these things. So if we make a list here, you might see things like SO4 -2. You might see things like OH -1, NO3 -1, PO4 -3. These are all polyatomic ions. And if you remember earlier, we talked about monatomic ions and polyatomic ions. These are polyatomics. What you'll need to do is refer to the list that was given to you, and that list has a whole list of everyone, now not everyone, but many of the most common polyatomic ions out there. And so in this list, we have things that you can see like, I've got ammonium and acetate and benzoate and carbonate, iodate, here's that nitrate, phosphate. There are lots and lots of these. These are just some examples. They're all available on your sheets. Okay? So, as we go back here, we're simply just looking to see what kinds do we have. Well, SO4 is a sulfate. Okay? OH is hydroxide. They're groups. They're groups of atoms that did not completely form a compound. Nitrate, phosphate. Okay? These groups really are no different than individual atoms. If I had CaCl, okay, and I tried to make a compound, I'd look at calcium's charge as a +2, chlorine's charge at a -2. I'd cross those charges, and the compound would be CaCl2. Okay? But what if I came across Ca and I came across OH? OH is a collective group, and so we use parentheses to indicate that polyatomic ion. Now, calcium itself acts as a +2. This hydroxide, or polyatomic ion, itself acts as a -1. Could I cross these like I did the binary? Absolutely. I just have to make sure I respect the parentheses. So this 1 will come to here, this 2 would go to there, and we'd end up with calcium hydroxide, CaOH2. Okay? Now let's look at one that maybe is just a little bit tougher. Let's look at magnesium and phosphate. Okay? Magnesium is a +2. Phosphate, put it in that grouping, is a -3. We see automatically that they don't equal. Well, I'm going to move this 3 down here like I just done a second ago, but I'm going to move this 2 down, but you have to be very careful. This 2 must go outside of the parentheses in order to respect that compound, because we don't want to have it look like this, PO42, because that's not what happened. It's not 42 atoms of oxygen, it's PO4 2 times. And so when I move this then, my formula would be Mg3, PO4, 2. Okay? Now, as we've shown before, and you learned the other day, what happens when we have multiple charges. For example, copper hydroxide. What if I have CuOH2? Well, you know, there's two types of copper. And so if I wrote this name, this is copper hydroxide, the question would come in, is this copper 1 or copper 2? Well, we have to use that same method we used the other day. We reverse that charge there, put that 2 there and that 1 there, and recognize that copper 2 hydroxide is technically what's there. On the flip side, if someone were to give you a name, like let's say manganese 3 carbonate, okay? Carbonate, okay? Well, as we go to put this together, I know that manganese is a +3 in this instance. I know that carbonate, from my polyatomic sheet right here, carbonate is CO3, -2 all the time. So I put my CO3 in parentheses and a -2. Now I cross my charges, and I end up with manganese 2, parentheses CO3, 3. So it's going to be a little dicey. This is probably the hardest of all the naming that we've approached so far. But if you keep the rules in your head straight about binaries first, ionic or covalent second, it'll all kind of sort itself out.